Hello guys, let's solve another LeetCode problem, House Robber 2. We are solving blind 75 LeetCode questions. We are in the list of dynamic programming. We already solved House Robber, and now it's the second version of House Robber 2. So let's talk about the previous problem, what we solved, House Robber 198, right? So you are professional house robber planning to rob a house along a street, and the input is actually a list of integer where each of the item represents how much you can earn. Only constraint is that you can't rob the sequential house. So the main difference between house robber and house robber 2 is that this is in a circle. So if you rob house number 1, you can't rob house number 3 because 1 and 3 are sequential because they're in a loop. So we can use the same type of algorithm what we use like dynamic programming, but these will be a little bit different. And we will go into detail how it will be a little bit different and how we can use the similar approach to solve the house robber 2 problem. So let's get into it. So we have few numbers, right? So 2, 3, and 2, right? So let's write it here. So 2, 3, and 2. So these are the 3 house number, right? And so if it's a problem number, previous problem like house robber, the result would be 4 because then actually 2 plus 2 is 4. There's the maximum you can rob because 3 is not the maximum one, right? But for this specific problem, house robber 2, you can't do 2 and 2 because this first house and these house, these two, these are in a loop. So you can't rob both of the house. So in this case, the answer is 3. So to solve this problem, we will use same like a DP table for this case array. And for this array, just see what we want to do. So we'll start with 0. And this 0 means actually the 0th house. Next, what we want to do, there are 2 options, right? So we can include this first house. So there are 2 options. One option is actually, do you want to include this house? And second option is actually, do you want to exclude this house? So if these are 2 options, then we will do our calculations. So let's at first think that actually we will exclude this house, right? So the first option is excluding this house. So to exclude this house, what we'll do in the dynamic array, DP array, we will put as a 0 for the first element. And then we will use the similar type of recurrence relation what we use before, and then find the solution. So what we'll do if we exclude these one, the first element, so the first element is 0. Now when you go to 3, you can take this 3, right? So your result is basically 3 at this time. And when you go to the last one, same thing. When you try to include 2 and the first value is right now 0, you can't. So then it will become maximum is 3. So this one is still 3. So this is your excluding case, right? So next, consider about actually when we want to include the first house, right? So for this case, we will draw the same thing. And for efficiency, we'll basically use the same table, but your first element has 0, 0th element. These element for first guy will include this 2 here. And when we want to calculate the next value, we'll try to see actually, can we include 3 or actually the maximum, right? So this is 3. And keep in mind that for this including matrix, since we are including the first value, we don't want to calculate this value for this one, right? because we can't take the last house because we already included the first house, right? So this including means actually the first house, and this excluding means excluding first house, right? And finally, what we will do actually, we will find the maximum of these two, right? So if you can find the maximum of these two, that's actually the maximum amount you can drop. So let's go ahead and implement it and talk about more how we can approach the problem. So this is our nums. And same thing, if you have only one house, you can just return the nums of one because you will just pick that house, whatever value it's in there. We need a DP table, so we'll start with 0, all of them. And this DP table, we want to make it size 1 more than the previous, the size of the integer array. So at first, for the first case, we want to start with, this is the case, we'll just write it as a comment, right? So excluding the first house, right? And in that case, your DP1 would be 0 because you're excluding. And for I in range, one to n, you want to do dpi plus 1. So you want to calculate all the values of dp, and you want to get the max of nums of I plus dpi minus 1 or dpi. So that's how you have all the values. Now for the second case, if you want to include the first house, so if you want to do that, then your dp1 would be the value of the first numbers. So we'll get the nums of 0. And keep in mind that when we are calculating these one, we want to make sure we don't go to the last element because we can't take the last house if we include the first one. And in this case, dpi plus 1 equal to max of nums of I plus dpi minus 1, and then there is a dp of I. And when you are done of these one, then you can just return the max of the two values. So basically dp n minus 1 dpn. So let's run the code and see actually if it's something wrong. No, that looks good. Let's submit it, and then we'll talk about the runtime complexity. So yeah, it beats 100%. So let's talk about the runtime complexity and space complexity. So runtime complexity, we are basically going through the loop once here for I plus 1, and again 1. So it's order of 2n, basically order of n. So linear time. So this is a linear time algorithm. For the space, you can use 2n space if you use two different tables, right? DP, maybe excluding and including, but you can basically reuse the whole table. That will not change anything in the runtime complexity wise. So space complexity and runtime complexity both are linear in this case. So you are using the DP multiple times. Yeah, that's pretty much it. So that's the solution of this house rubber 2 dynamic programming, and it's a medium difficulty problem. So thanks for watching. I will see you in the next LeetCode video.